in this part, I'll switch the gear a little bit and focus on a specific type of social media, which is what we call social multimedia. So we are talking about things more than just text. And typically we include things like images and other factors. This is just a little bit promotion for our new Institute for Data Science at the University of Rochester. Actually, if you go to our homepage now, it doesn't look like this anymore. But I liked it so much, so I did a screen capture. The reason I like it is, so I'm a computer vision person. So I like pretty pictures, but these pretty pictures actually mean something. In fact, each thumbnail picture represents the research of one of our researchers. Just to get the audience involved, can you take a guess which thumbnail represents me? Which one? Mona Lisa. Okay, not the second one. Yeah, Mona Lisa is right choice. But this is not an ordinary Mona Lisa picture. In fact, if you look carefully, there are words in the picture. So that's the artist's rendition of a picture is worth 1,000 words, which is what I do. I try to extract information from images. So like I said, I work in computer vision as well, and data mining is the other area. But these two areas in my group actually are related. It doesn't really matter whether we do computer vision or data mining. We rely on big data, and we also rely on machine learning to do the job. Just to start with some background about how social media has become. So this is how people used to watch TV. Okay, so people gather in front of TV, and you can tell from the image they are watching a football game. And this is how people watch TV today. Okay, so you can see the huge difference. Now they are not looking at one screen. In fact, they are looking at least 2 screens. The TV is there, but then each one's looking at their phones and doing something. What are they doing? Social networking. And then the third picture is basically a snapshot of our graduate lunch. And you can see that, okay, the TV was on, but students, they have their laptops and other things. They are doing all kinds of things. In fact, watching TV has become a multitask activity. So that's a breakdown. So people are talking to others, either next to them or on another phone or across the internet. They are eating and they're doing all kinds of things. It's actually not just a phenomenon with young people. Okay, so I only have one daughter, but you can imagine in a typical family, this is what they do. So even a dog can have a phone to look at. So that's a little bit exaggeration, but this is reality. So it's, again, a presidential election year. And these are 2 pictures. I really like them because they tell a lot about how time has changed. So in 2009, when Obama took the office for the first time, so this was during the inauguration. So the first family was actually quite attentive to what's going on. And then 4 years later, when he won again and swearing, you can see that none of them was actually paying attention to the whole ceremony. Okay, so that's very interesting. So that leads me to this point that, okay, so we all know what a sensor network is about. It's about having a bunch of physical sensors which can collect temperature, sound, pressure, and other signals. But today we have a new type of sensor networks. It's built on people. Okay, so each of us is a sensor. Okay, or you can say each device we have is a sensor. Okay, so as a result, each sensor can collect all kinds of information. So you are very familiar with text-based information, which Yuheng and Yuru have talked about. So I just want to characterize the new type of sensors a little bit with these properties. So we can easily see that every one of us is autonomous. So we have our own will. We are all intelligent. So we decide what information we want to collect. And we are actively seeking information. And we move around, certainly, right? And compared to the old sensor networks, there's really no need for maintenance. We know if we are hungry, we need to eat, we need to sleep, we take care of ourselves. So there's no maintenance cost. But I want to emphasize the three properties in green. I want to emphasize today, actually, human-based sensors are inherently multimodal. So we can collect all kinds of information. We have 6 sensors, right? So it's not just limited to one particular modality. And because we are people, we actually socialize with each other. So that's something that physical sensors or mechanical sensors don't have. And finally, I think you've seen Yuheng talking about sentiment. So we have feelings. So sentiment is very important kind of signal in this kind of sensor networks. As I promised, so I will focus more on image-related information. So why do we care about imaging-related information? Because image is really universal language. So today, social media is in everywhere, every corner of the earth. So all kinds of languages, I actually only understand a couple, okay? But everyone can understand what the image content is, okay? And as I mentioned, image contains a lot of information. So before this phrase, that image, a picture is worth 1,000 words is only a metaphor, but today is actually true. If you work in computer vision, you know that a popular way to represent an image is called bag of visual words. So in that regard, you can look at the face. It's actually made of eyes, nose, and other facial features. So it's a bag of words, much like what you normally do with a document. So this expression is literally correct as well. So we are here to talk about what we can do with data, lots of data. So what's the biggest of big data? I would argue that's image data, because it takes so much bandwidth and storage to store or transmit image-related data. So according to Cisco, today 70% of the internet traffic is consumed by visual data, images and videos. And the single biggest consumer of the internet bandwidth, can you take a guess? Yes. Okay, Netflix. A lot of people tend to guess YouTube, but compared to Netflix, YouTube is a small dog. Okay. Because in Netflix, you watch high-definition movies. This just basically to recap that nearly all social media platforms today gives you ability to share images. Okay, so even Twitter, which started with just text, now allow you to embed images, and then each second, lots of image-related content is generated in all kinds of platforms. Before I move on further, I just want to give social media a formal definition. Is actually trivial. Basically, it's multimedia content generated for social interactions. And this is just an example. This was an old screen capture of my Facebook account. It actually illustrates several points I already made. First, there are all kinds of languages, so I have all kinds of friends. A lot of researchers, some of them speak Japanese, and then some of them speak this language, which looks like Greek. It's actually Greek. Okay. But everyone can understand these two images, right? Blue sky and grass and so on. So this is how we view the image data in social media today. So obviously we have the pixels, the frames, so that's image video data. But a lot of them actually carry either timestamps or geolocation information. And then obviously such visual content is shared with other text information as well. And like I said, social multimedia is generated for social interaction. So the bigger context is the user network, social network. So we are looking at essentially a heterogeneous information network where the nodes can be of different types. Okay, so they can be people, can be images, can be documents, can be emotion, sentiments, or can be just a page or a storefront, whatever. Okay, so we actually started working in this area, social multimedia, back about 5 years ago, when I collaborated with Yuheng and his students. So this was some early work. So we actually crawled the data from Facebook. So these are public Facebook pages. So for celebrities, business, and so on. And then we treat all the data as a heterogeneous information network, and then we use random walk and other algorithms to mine information. So this one is actually an example about clothing topic. So if you are interested in clothing, then we can look at the entire network of Facebook, not the entire network we collected. Okay, then we can discover using data mining technique to discover top users, which are people who talk a lot about clothing, top photos, as I show in the second row, and then top pages as far as clothing is concerned. So as you can see, they actually make sense. They are like Banana Republic, A&F, Hollister, so on and so forth. So that's some early work we did. So that's the beginning. And around the same time, this again was with Jiebo's group. So we took all the geotag data on internet, and we tried to discover the best route or best trajectory to tour a city. So this is London. So we get 30,000 geotagged photos, and then you can use clustering to discover all these colored clusters. So each cluster, as you can imagine, corresponds to a attraction spot. So different spot where people take a lot of pictures. And then these pictures were collected from Flickr, so they have associated text. So from the tag, you can mine the name of each spot. So that's what I'm showing you here. So London Eye, British Museum, so on and so forth. And then once you determine the name of each spot, you can look at one particular user picture collection. Then you can determine the sequence of attractions this person went through. So like Alice went through London Eye, Big Ben, Downing Street. Okay, that's on one day. The next day she did something different. And then we collect this for all the thousands of tourists. So we could, actually, I don't have another slide. So we use sequential pattern mining to discover the most popular trajectories tourists took. And also we introduced the idea of diversity. So we want the top trajectory to be different enough from each other. Okay, so like you have been in London once, the next time you may want to do something different, then you go down the list. Okay, so this is the idea. Basically, is the crowdsourcing idea. So we discover what's wisdom from a crowd. Okay, so each tourist did something subconsciously, but then we put all the information together. We can discover, okay, what most people do in this particular city. So that way you don't need to consult a travel agent. So that's 2011. And since then, we and other groups have taken this idea to do a lot of things. I'm listing some of them there. Most notably, we use this idea to monitor public health, environment. I'll come back to this later. I want to give this 1 minute. So this represents a project called eBird. The whole idea is to study environment. So what's a good sensor for environment? Birds. Okay, but how do you track birds? Okay, the old way was you catch the bird and put some sensor on its feet. Okay, but that's not scalable. So the idea behind this eBird project is very very clever. So what they did is they rely on a particular group of people. These are bird watchers. So what do bird watchers do? They go out and look for certain birds, and when they spot them, they take a picture and share online. Okay, so if you aggregate all such pictures together, now you know where a certain bird is. Okay, so then you do this over time, then you can see that the migration of different birds. Okay, and then you do it. I can't play this animation right now, but you can imagine. So you can see this sweeping pattern from season to season, and then if you compare the pattern from one year to the other, you can sense if everything looks the same, then there's probably nothing changed in the environment. But if they come late, come early, then there's something probably with climate. If they change the route, then maybe there's pollution or whatever. Okay, so that's the idea behind this, and then it's based entirely on bird pictures taken by bird watchers. Okay. And there are other uses which I don't want to get in right now. I hope I can play this. Okay, this is good actually. No sound is better. So this is the system my colleague Henry Kautz built with his student. It's called Germ Tracker. So what they did is, this actually doesn't involve images. So what they did is, they figure out all the flu-related tweets. Okay, so this is based on a language model. So you can figure out, build a classifier to classify which kind of tweets indicate that the user is having flu. Okay, then some of these tweets have geotags, so you can actually put them on the map, like I was showing you. So this is a live map they built for Manhattan. Okay, so the warm the color is, the more sick people are concentrated. So what's the use of this? Well, you want to stay away from them. Okay, you want to go to the lighter color areas. So this is their first work, and later on they did something. Actually, was adopted by the government, by the city of Las Vegas. It's about using tweets to monitoring food poisoning. Okay, so what they did is they use the same approach. Basically, they can determine what kind of tweets indicate that this user had food poisoning symptom, and then they can relate that back to what restaurant they had their food. Okay, so so this thing was so successful that the city of Las Vegas is using this to monitor all the casinos and food quality, food poisoning. This whole effort is what they call Twitter health. So that's sort of like a teaser for what I'm going to talk about more in the next hour or so. So this is, in my opinion, the two most important social signals you can extract from social media. One is user information. The other one is sentiment. So that's in my opinion. So I think Yuheng has talked a lot about the events, and then he also related the events to sentiment. Essentially, in the end, what's the social aspect of events? I would argue it's sentiment. Okay. So I'm going to go through a few projects we did in terms of finding fine-grained social user interest profile from social media content. And in this case, we relied on Pinterest, because Pinterest is about images. So if you use Pinterest, you know Pinterest is about collecting images you like. So you can create what's called a board. Once you have a board, then you can pin images on the board. So each board essentially is a image collection in which all the images are related to one theme. Okay, and in fact, okay, so I'll talk about that later. So I have two examples here. Okay, so this first row are the boards of one user. We'll call it user A, and then this second row is the boards for user B. You don't have to see exactly what's going on, but I'm sure you can agree that user A is likely to be a young male who's tech savvy, okay? And then the second user B is likely to be a young female, just based on the images they like, okay? So in fact, this is something we did a few years ago. Basically, we took the images and image boards, and we try to decide whether the user is male or female, okay? And we were able to get to some 0.7 or 75% accuracy. So that's our early attempt. And later on, we did something more comprehensive. So again, if you use Pinterest, you know they classify user interest into 34 categories. Actually, 33 to be exact. So the 34th category is for other, okay? Anything that you can't put in the first 33, you dump in the other category. So, so essentially, each user is represented by a 34-dimensional vector. So what we wanted to do in this work was to use the images to reconstruct this user interest vector, okay? So you may have a question, you say, how do you know you did it right? Well, when a user starts a board, he's supposed to choose a category, which is one of these 34 things. Okay, so we put that information aside. That's our ground truth. Okay, so now our job is, okay, we put that aside, and we only look at the images and perhaps the captions of the images. We want to predict or estimate that ground truth. Okay, so these ROC curves are essentially what we were able to accomplish. The lower dark blue represents what we do this way. Okay, so we do it for individual images, then we average them within the same board. Okay, so that's a baseline. The second one, the red curve, is we don't do it individually. We treat a board as a one entity. So whatever we do, the constraint is that all images should share the same category. Okay, so then based on that constraint, we were able to do better. And the final cyan curve essentially is people don't have random interests. Okay, so among the boards, okay, there should be correlation. So if you like, if you love animals, you probably don't like hunting. Okay, that's just an example I make up. So we also discover such correlation between different interests over a large set of users, and then that gives us a further boost. Okay, so this is one example. And we did something even crazier recently. Okay, so people use avatars on social media, Twitter, and these are actually from the Chinese Twitter, WeChat. So you can have your own picture. Okay, some people do use their own picture, but some people use cartoons, animals, flowers. In fact, there was a paper last year, I think, about understanding what the type of person the user is based on their avatar, but that has to be a real picture of the face. But in this work, what we did is we don't care if it's a face or not. So basically, we use computer vision techniques to train to recognize these things. So I think these are avatars of guys, okay, and these are avatars of female. And so we did a small scale study. We're going to do more. So we get to 72%. Think about it, it's actually quite amazing. The only information we had is this little thumbnail, okay? And we could guess their gender 72%. And that's not the most interesting thing. What most interesting thing we discovered was we asked humans to do the same task. So we didn't ask the user to recognize their own friends, okay? We asked a third-party person. And with a male third-party person, this is what he did, okay? So it's 70-some%, okay? And then this is with a female annotator. If you stare at these two matrices for a second, it's actually quite interesting. Males are better at telling the avatars of the other, of girls, and vice versa. This is quite fascinating, okay? Again, we're gonna do more to verify if this trend holds true. Okay, so getting back to social media sentiment, I think like Yuheng has talked about, but we are more interested in this type of social media where you have text and images. And in fact, these things are called image tweets with the images, okay? I'm not a Justin Bieber fan, but some are, okay? I want to use this example to make a point, okay? So this tweet was like one of the most tweeted, retweeted tweet in history. And that was what Obama did after he won the re-election. So he basically just tweeted 4 more years. So you could try to infer the sentiment from the words, which is 4 more years, but I think that's very difficult because it could mean 4 more years in the White House. It could also mean 4 more years in the jail, okay? So which is completely the opposite, right? But fortunately, he attached the picture of him hugging with Obama. So actually, from that picture, like, I don't think there's ambiguity. That's trying to convey positive sentiment, okay? So that's what we try to do here. So sentiment or affect sensing has been around for quite a while. In early days, you have to put a sensor on people's head and get some signal in order to know what they are feeling. This is called the Plachik wheel. It's from the psychology literature. So humans have 24 types of emotions, but in fact, they are not 24 independent emotions. In fact, they are organized in 8 valence, and for each valence, there are 3 arousal levels. Okay, so like there's grief, sadness, and pensiveness. Okay, I don't have to spend too much time on this because Yuheng has already talked about sentiment analysis, especially using text-based technique. But also, thanks to Yuheng, I don't have to convince you. Doing sentiment analysis on tweets, which are sort of informal text, is quite hard. In fact, we did an initial study. We collect a bunch of image tweets, and we used the state-of-art NLP tool to get the sentiment for these tweets we had. And the accuracy was actually not good. It was 61%. So that's because, like you have mentioned, the text is of low quality, and also there's a lot of noise in it. So even the state-of-art, although they can do 95% on movie reviews and product reviews, they can only do 61% on tweets. Okay, there's a specific tool we used. We also use. It's called Sentiment 140, which was designed just for tweets. So you only analyze up to 140 letters. So we decided that we're going to try to make use of image information. But before we started, we actually did some statistics. We found out something very interesting. So this plot essentially shows us, so this is the proportion of image tweets, and this is the proportion of positive tweets. If you read this chart, what it essentially says is users who treat a lot of with images tend to spread positive sentiment. Okay. Again, I didn't make it up. It's what the data says. Okay. So how do we extract sentiment signal from images? So that's a relatively new area in computer vision. This was what we believe to be the earliest published paper on this topic. It was 2010. So in 2010, that's prehistoric, pre-deep learning, I mean. Okay, pre-deep learning era. So what can people do? So the only thing people could do is extract color features, maybe sift features, if you have heard it. Okay. So this is the result of what they came up with. So essentially, they found out, okay, all these colors are correlated with positive sentiment, and these are correlated with negative sentiment. If you take a step back, you look at it, say, wow, what it says is positive, no, warm colors gives you positive sentiment. Cold colors give you negative sentiment, except this particular color, which you probably can imagine is the color of blood. Okay, and then you went on, you go on to see what the these structural features can tell you, and it seems to suggest that if you see dark spots, you get a positive feeling. You say, oh, okay, and then you see bright spot, you get a negative feeling. You say, wow, why is that? Okay, actually we don't need to understand why that is. We just need to look at the accuracy reported. The accuracy they reported is a grand 51%. Okay, so random guess is 50%. So in spite of these features, okay, they are not doing anything. Okay, so we actually around 2013 we decided we're going to try something a little bit better. What we relied on was not color, texture, this sort of thing, but something called visual attributes. Basically, from images, you can calculate these things like, you know, glossy, people playing, people socializing, positive facial emotion, so on and so forth. And then once you get these mid-level attributes, they are already words and semantic, right? So you can build a classifier on top of that, which would lead you to either positive or negative sentiment. And that's what we did. Guess what accuracy we achieved? We achieved 61%. This is not the first time I mentioned 61%. Okay, 61% doesn't sound like much, except you have to remember the NLP tool did 61%. And this is actually not the state of art in computer vision. So it already matched NLP. So we were quite encouraged. Okay, I'm going to skip this. This is the details about how you calculate visual attributes. There are actually 102 of them. I just want to mention at the same time, Columbia University, Professor Shifu Chang's group did something similar in spirit, but they did it in a more elaborative fashion. What they did is they created something called Sentibank. The Sentibank is a collection of classifiers. Each one is designed to capture what's called an adjective noun pair. So beautiful flower is adjective noun pair. Okay, smiling face is adjective noun pair. So how many do they have? They have 1,200 of them. Okay, remember I only have 102 attributes. They have 1,200 ANPs. So they trained that. We both tested on the same data set. And incidentally, they also got 61%. Okay. And their work, if you look in the literature, is called Sentibank, because they have a bank of 1,200 ANPs. And our work is called Sentribute, sentiment attribute. Okay. All right. So like I said, it's 61%. So then, you know, deep learning was all the rage, so we figured, well, if you can do well in object detection with deep learning, can we try it on sentiment analysis? So Yes, you can try, but it's actually not easy, okay? Because a deep network needs a lot of data to train. So if you close your eyes and imagine, wow, there are so many emotions and sentiments that can be expressed by images. So if I want to do a good job, probably I need 1,000,000 images, okay? And I need a million images labeled. Okay, so wow, who's going to label this 1,000,000 images? And also, sentiment is kind of subjective. You can't trust one person. You need to ask multiple person, right? If they have consensus, you know this image has this sentiment. So we actually did a calculation. Even with the AMT, Amazon Mechanical Turk, the cost is prohibitive. We could do it. So we said, all right, now we're stuck. Then we say, actually, no. We already have a 61% classifier. We can use that classifier to label 1,000,000 images. Okay, so, oh, great. We have 1,000,000 labeled images. But wait a minute. Okay, you can't trust the labels because it's 61%. So it's like every 3 images this algorithm labels, one of them is going to be wrong. Okay, and you don't know which one is wrong, actually. Okay, so but we didn't have any other thing. So we're going to say, well, since deep learning is so great, why don't we just give them noisy label training data, see what happens. So it actually did well. Now the result is tested on a different data set, right? Independent, not in the training case. So we get 70%. So I said, oh, okay. So deep learning actually does have some magic. But now that we have an even better one, we can take this 70% classifier and relabel that 1,000,000 images again. And then we think if we could figure out which ones to throw away, and if we can keep the higher quality machine labeled data, we probably can do better, right? So how do we know which ones to throw away? If you had perfectly labeled data to begin with, then the confidence spit out by the convolutional neural network can be used to guide the selection. So if the confidence is high, you keep it. The confidence is low, you don't keep it. Except we didn't have perfectly labeled data as training data set. So we can't use we don't have confidence in the confidence value, okay? So that's the dilemma. So what we do, we say, okay, at least we can use this confidence value as a probability to sample the data, okay? So that's what we did. So we have this structure. So let's say we use, basically, if the confidence is high, then it's more likely we retain this sample, otherwise we throw it away. I just want to emphasize, if a sample is thrown away in this round, it doesn't mean it's going to be thrown away next round, because it's probabilistic, okay? So we do this like 4 or 5 times, and eventually we got actually better and better results. So this is just to visualize what went on. So these are the output of the first convolutional neural network layer. So you can see these are essentially visual patterns the network has learned. And then below that is the PCNN, basically stands for progressively trained CNN. You can see that these patterns look, number one, similar, but these ones look less noisy than these ones, okay? So there is some improvement going on. And then on the right are some examples of images classified into positive, negative sentiments. So the top half are the ones supposedly to be positive sentiment, and the bottom ones are supposed to be negative sentiment. What are the columns? The columns are different methods. So these last 4 are based on color and texture, shift, whatever. And the rows are, so these are the top 5 choices by each algorithm. So you can see that with low-level features, even in the top 5, you are getting junk because they don't do much. It's 50% or 51%. These 2 rows are the Sentibank and Sentributes. Both are 61%. So they make some error, but mostly okay. And then these are the results of the first run CNN and refined progressively trained CNN. At least in top 5, there are no errors. Okay. So these are just some details. I won't go through. You can check the paper. Yeah, so we also break down our data set in terms of human opinion. So there's a group where 5 Amazon Mechanical Turk workers agree, 4 agree, and 2, 3, 3, 2 split. Okay, and you can see the sort of the results we were getting. Okay, so yeah, I'm gonna skip all the numbers. So that's our first attempt at extracting sentiment from images. But ultimately, our goal was to extract from social multimedia. So as soon as we have a reasonably good image sentiment classifier, we could consider putting these 2 pieces together. And there are, in multimodal analysis, you can have different ways of fusing different modalities, right? Early fusion, basically, you just put the feature vectors of the modality together and train a classifier. Late fusion, basically, you do it individually, and then you combine the decisions. There's something called CCA, canonical correlation analysis, which is common. And then this CCR is what we propose. It's called cross-modality consistent regression. This is something we presented at Wisdom this year. So the idea is, after we look at a few image tweets, these are image tweets. So you can see that this is an example where the visual sentiment and the textual sentiment clearly align. Okay, and then this is the same thing. They are both negative. But there are some examples, either one of them is neutral or you can't quite tell. We just felt that if you want to impose the consistency constraint on each sample, that's too strong because they don't necessarily always align. Okay, so we take a step back. We decided we're going to do something weaker, but still connect to 2 modalities. So what we did in the end is, imagine we have a data set, and then we use each modality or the combination of 2 modalities to predict the sentiment for all the samples in that test data set. In each case, you would create a distribution of sentiments, right? So we just require the distributions to be consistent, not on an individual basis. So basically, this formulation, you can see these D's are actually like KL divergence kind of thing. And then these are regularization terms to make sure we don't overfit due to so many parameters. So in the end, we were able to report that using this formulation, we could do better than all the baselines. I don't have the CCA in there, but CCA is better than early fusion and later fusion, but worse than CCR. And then this year, we're going to present another paper at ACM Multimedia in which we actually build an end-to-end system to predict the joint sentiment. So far I've talked about just binary cases, positive, negative, and maybe neutral. But like I mentioned earlier, human emotions are richer than binary, right? So we decided we're going to try to do some fine-grained classification of emotions. And we decided we can go for the 8 valence levels first. So I'm showing you examples of like amusement, art, contentment, excitement, so on and so forth. There are 4 positive, 4 negative emotions. And then we looked around in the public domain. There was hardly any sizable data set. The largest data set for these 8 emotions is about 1,000 images. So you certainly can't do deep learning on that. Okay. So we decided we're going to do some work for the community. So we actually started with 3 million images, and we didn't start from random images. We actually collect the images from Getty Images. Okay, Getty Images is a company that hires professionals to take all kinds of images. The reason we use that is the image quality is guaranteed, and also professionals know how to frame them pictures to convey sentiment better than average people. Okay, so we started from 3 over 3 million images. The reason I call them weakly labeled is we were using the descriptions of these images to label the emotions, but then we use humans to verify that machine label. So as a result, we actually eliminated lots of images. So in the end, we don't have 3 million images anymore. But we ensure that even for the smallest class, which I believe is fear, because you don't get many fear images, we have over 1,000 images. And then, so we get an image set, and then we use the progressively trained CNN technique to get a baseline performance on these emotions. So the highest performance we got was close to 60%, and that's actually quite high. In other words, the baseline is not a low baseline. Okay, imagine the prior. The prior is 108 is 12%, 12.5%. So this is almost 5 times of the prior, or of random guess. Okay. So this data set is available to the community. Okay. So this is related to sentiment, and we kind of expand our scope. We decided that we're gonna try to understand more than just sentiment. Now we're trying to understand personality from social media. So this is our work published this year in ICWSM. Basically, what we're gonna do is, based on the language you use in Twitter, we're gonna guess what job you have. Okay. These are just some of the examples. Basically, so you see blue tag clouds and red tag clouds. The blue tag clouds are basically the words that a type of job, people of a certain type of job like to use. Okay, and you probably can have a guess already, right? Because you mentioned story, writer, journalism, blah blah. And then these are smaller topics by this type of job. Okay, and what are the red? Red are the red tag clouds are the ones they use least often. Okay, they don't say anything about management, interface, marketing, and so on and so forth. Okay, so that's one example. And we were using this visualization method proposed by Schwartz to visualize our results. So how do I know people's job? We go to LinkedIn, right? So this is just my LinkedIn page. But we quickly realized we can't rely on people's own classification to label their occupation. Here's why. Okay, so that's me. That's Henry. Henry is my colleague, and he said his occupation is higher education. Okay, and then Adam said like is his brilliant student who works at Google now. He said his job is research. Okay, all these are correct, except I didn't choose higher education research. I could have. I just thought they don't tell much. Okay, it's too broad. Okay, so what I'm trying to say is you cannot rely on that field to specify a person's occupation. So what's more reliable? It's this. It's people's skill set. So I'm sure everyone has LinkedIn, right? More or less. Okay, so you have all your skill sets, and if you look at my skill set and Adam's skill set, now they look a lot alike, okay? And that's not all. We get these endorsement numbers. If one skill gets more endorsement than the other, you're probably more of an expert in that domain than others, okay? So now we can represent each person's occupation as a vector, which we just read these endorsement numbers and form a vector. And then we take all the vectors of all the users we collected, and we do clustering, right? And we decided that we're gonna, you always have to choose a number, so we choose 8, okay? So there are 8 types of primary occupations: marketing, administrator, so on and so forth. Okay. And then for each type of job, today I think each type of job requires multiple skills. So it's not surprising that each type of job is represented by second skill, first, second, third, so on and so forth. Okay. And okay, so you may ask the question, how do you know their Twitter account and LinkedIn account? Okay, so we went to this site called about.me, where some people care to share what they are about. Okay, so now you know the connection. But if you don't know, there's a paper by Huan Liu's group on how do you estimate like which accounts are actually of the same person. Okay. All right, so also we use an open vocabulary approach, so we didn't have a limited or closed vocabulary, okay? So these are just some of the examples, like administrators, they like to use make a difference, courage, honor. I think they sound like Hillary. Okay, just kidding. And then startup, I'm surprised money is not in there. I thought that's all they care. Okay. And then software engineer, office clerk, okay? So next thing what we did is we use this IBM Watson Personality Insight API. We basically take the language, the words they use, and map that to the personality space, the big five, as I'm showing you here, O, N, A, E, C, okay? And then we aggregate the personality traits of a particular operation. Okay, so now you are seeing these 8 types of jobs, occupations, and they look different, right? This is called a radiograph. So, not surprisingly, I think the software engineers, they are short on E. Okay, you may disagree, but again, this is population aggregate data. Okay, and then as you can imagine, you know, marketing people is strong in C, okay? So on and so forth, okay? So now we have this. We can turn around. For each user, we get the personality traits, and we use what we discovered to predict what their job is. And these are the numbers and different approaches. So the F score is around 0.8, 0.7, 0.8, okay? Precision recall, so on and so forth. And also, not all occupations are hard or easy to predict. I think software engineer is very easy to tell, okay, because they say things like that. I don't know, Java, Python, okay, data, and so on, okay. So that's that. Okay, what is this? Okay, so this is Terminator 3. So we all heard this fear that AI is going to take over the world, and so on and so forth. And for me, I initially get this idea from Terminator, okay? And how many of you seen this movie, Terminator 3? Okay, 1/3. Okay, in my opinion, this is the worst Terminator movie. Okay, but this movie has the best part I like. It's the part I have here. Okay, so this is a conversation between Arnold, which is the protector of John Connor in this episode. So John Connor was chased by this female Terminator, and he was driven nuts, and he said, okay, forget about it. She wants to kill me, so I just kill myself and be done with it, right? So, and then Terminator says, you can't self-terminate. And then John Connor says, I'm a human, I can do whatever. You're a machine, you cannot self-terminate, right? So they went on, and then typically in Terminator movie, when Terminator is thinking or searching, you see a red screen, right? And the numbers are going on, right? So that's what's going on. And then after that, for like a second or so, he said, the part in bold, it says, based on your pupil dilation, skin temperature, and motor functions, I calculated 83% probability that you are bluffing. Okay, essentially. That's the part I like. Why do I like that? Okay, because that was science fiction, and now we are turning that into reality. Okay, so why do I want to turn that into reality? We were motivated by actually a big issue in modern society. That's mental health. So this is too big an audience, so I want to ask you this question. The question was actually, what's the percentage of the population you think had a mental health problem in their lifetime? And I get all kinds of answers. Like I went to Microsoft research, they told me it's 100%. Okay, and then I went to some party schools, they said 30%. Okay, the correct answer is 46%, and that's the number by the CDC, Center for Disease Control. So you can imagine half of the population had some issues. I'm sure you had some of these issues before the KDD deadline. Okay, at least the anxiety. So now that every other person has issue, how do we deal with that? It turns out the current health systems cannot handle it, because mental health is a problem that you cannot do a test and figure out, right? You cannot test the blood or do an MRI, CT, and say, okay, this guy has mental problem. Okay, the method is actually quite expensive. You have to talk to a shrink, and then after half an hour or an hour, okay, I think you have issues. Okay, so this is not a scalable approach. So what we want to do is we want to rely on computer vision and data mining to do that. Okay, and we want to do it in a way that doesn't take much extra. Okay, and it turns out it's possible today. Okay, because of the advance in computer vision, data mining, and also the fact that we have widespread use of mobile devices and social media. So here's how we do it. So every day, you spend hours and hours staring at a screen, like I said in the beginning. So it could be your phone screen, it could be your computer screen. Okay. So when you are staring at these screens, why can't these things stare back at you? Okay. Why do you want to stare back at you? Because from the video signals, we can extract lots of signals that can reflect your mental state. For example, this may sound a little bit crazy, but we actually can use video signal to estimate your heartbeat rate. Okay, and you say, oh, I can't do that. No, you can't do that, but machines can. It turns out when your heart pumps blood back and forth, the skin color actually changes ever so slightly, which is not visible to us, but it's measurable by a vision algorithm. So we did this. The initial idea came out of MIT. They did it for baby. But the good thing about babies, okay, their skin is very transparent, so that's good. Also, when they are sleeping, they don't move. Like when you are doing your phone, you move, you don't stay still. So what we had to do is we have to use tracking to make sure we are staring at the same spot on your forehead. In fact, we stared at 100 spots at the same time, and then we average the result. Okay, so that's what we can do with video signal, but we can also analyze your social media content. Remember, we can do sentiment analysis, right? So we can look at the sentiment of the things you read, or the things you said, okay? So that's the idea. I don't want to get into details because I have other things to talk about. But the idea is, so we did a user study with 27 participants. We bribed them into our lab, okay, for an hour. But if they sit there for an hour doing nothing, you can't get any emotion signals. So what we did is we asked them we compiled an hour worth of tweets, okay, and say, okay, you sit here and just go through all the tweets for this hour. So that's the stimulant, and we're trying to stimulate some emotion out of them. And they look like this sort of thing. So this is ground truth. How do we know ground truth? We actually ask them. We check with them every so often. And then we got all the signals, either from the video or from the social media, and then we can do estimation. So you can see that we kind of do all right, okay? And then we can impose some temporal smoothness constraint, because your emotion cannot change suddenly, right? So with the HMM, we can do better. So that's like 70-some%. So that's for normal people, quote, normal people. And then we did do a study with depression patients, but the objective is different. It's not to tell whether they are depressed or not. We already know they are depressed. We just want to tell how depressed they are. Okay, so in medicine, there are 5 levels, but we have a very small data set because privacy and other issues. This is actually being practiced today. So like I said, because there are so many patients, so few specialists, so today they can't get everyone in. So what they do is they use FaceTime on iPhone to chat with some people for 5–10 minutes every once in a while. And based on the conversation, they assign a score. So that's ground truth we're trying to predict. And in this case, these are really depressed people, so they don't do social media much anymore. But since this is a live conversation, we actually can measure the mental state from their voice, not what they say, but how they say it. Okay, so that replaces the social media signal, and we can also do close to over 70%. So okay, why do we want to do this? Our goal is actually not to be a big brother and spy on everyone. It's because so many people have problems, but if you know you are experiencing problem, you could self-manage your stress level. So what we hope is, essentially, we're going to map everything we developed into a phone app. So it checks at you every so often, and it gives you an indication where you are. Okay, so if you are in yellow or orange, then maybe you should put down what you're doing, talk to people, do some exercise, so on and so forth. If you are in red, then it's a good idea to to get an appointment and see some specialist. Okay, and to preserve privacy, we want to make all the data collection and data analysis happen on the phone, so nothing leaves the phone. Okay, so that way we can protect privacy. We are doing lots of things that are related to users. So starting from user interest, personality, sentiment, so on and so forth. We actually want to lump all this into something called project genres. This is internal code for the research. So who's Janus? Janus is this god that has 2 faces. Okay, so we use that to symbolize many aspects of the same person. So we can know more and more about a user. Why do we want to do that? Obviously, targeted advertising is the first thing that comes to mind. But another usage would be like chatbots, which are becoming popular. So Microsoft has this this chatbot, and in fact, we talked to them. Actually, they were quite demanding. They said, well, you can tell the interest, the personality, sentiment from whatever the social media content, but we want to know the user after they say 1 sentence. Okay, that's too hard. That's like you ask a fortune teller what your fortune is. What can a fortune teller do? The fortune teller can only say something, ambiguous at the beginning. But I think with as the conversation goes on, and you can know more and more about the user, you can do better. And that's what's portrayed in the movie Her. Okay, so that's that. I think I have 20-some minutes. I want to change the topic in terms of the target of the research. So far I have been talking about what you do with individual users, but you can do the same thing for a group of users, right? A society. So in terms of the pulses of a society, so I listed so many topics. You can consider this as pulses of a society, right? From security to health to other things. Okay, so I think you have mentioned election early on. So most people, when they do election prediction, they use tweets, with text information. We did something different. We used images. Okay, so we started doing this in 2008. Yeah, and that time we were doing something very rudimentary. So we were just saying, Okay, the more you share images about a candidate, the more likely you're gonna vote for this person. But that ignored a major phenomenon in U.S. politics, which is called negative campaign. Okay, so you don't like Obama, it doesn't mean you don't share images of him. In fact, you want to share images of him. You just pick the pictures that in which he looked like a bad guy. Okay, right, like this, and then you copy some words, you stick in there, you spread all over the place, and unfortunately, a lot of voters are easily influenced. So, they saw that and say, okay, this is a bad guy. I can't vote for him. In the U.S., you don't have much choice. You don't like this person, you vote for the other person. Okay, so what we did the first time around was incorrect because we count every image you share as for the person. It could be against the person. And when it's against the person, it's actually a vote for the other person. Okay, so that's why we use computer vision technique to figure out the sentiment, and we correctly credit the image sentiment to the right candidate. And also, we consider so when you post an image up, other people will comment on that, right? So we also get sentiment out of the comments. And then we consider the electoral college system. We do it state by state, but that doesn't mean we need to do 50 states, because the red states, the blue states, they can always vote the same way. So we only need to worry about 8 swing states, and that's what we did. This was for the last election. We were able to do as well as Nate Silver, which we felt very happy about. So election happens every 4 years, and you say, great. Every 4 years we write another paper on election prediction. No, okay. You can't write the same thing, so you have to do something different. So this time around, we actually do some more fine-grained analysis rather than just say who's going to win. Okay, in fact, we don't know who's going to win. Okay, but we studied the issues with the candidates. So you heard that Hillary Clinton likes to play the women card. So we did a study to figure out, okay, how much is the women card worth? Okay, so how do we know that? Okay, so we actually study all the followers of Trump and Hillary. But you can't trust the followers because a lot of them are not real people. They are zombie followers. So you can't count on the followers and say, okay, Hillary has more than Trump, and she's more popular. So we decided that we're going to study unfollowers. Okay, people who used to follow Hillary but dropped her, or people who used to follow Trump and dropped her. So because we call that voting with feet, because you follow someone, you decided that's enough. Okay, so that means you don't agree with this person, right? So then we did some analysis to, okay, then you ask, how do you know the demographics of these followers, right? So remember I mentioned earlier, we can use the avatar to figure out their race, gender, and age, okay? And that's what we did. Then you say, okay, not all people use their real faces. Well, we actually tracked every single one of their followers. And then we have enough left in a population where a real face is used. And so we can figure out the age, gender. So then we figure out what problem Hillary has. Okay, so Hillary has an issue with a certain section of the population, and that's, according to our study, young women. They don't buy what she said. Okay, and then so he said, okay, Hillary has issues. Trump has no issues. Trump has issues too. So what section of the population does Trump have problem with? And according to our study, these are young parents. I think that's also explainable because Trump tend to say lots of offensive things, okay? And young parents are mostly objective to this sort of thing. So this is just an example of the things we found, okay? This one I want to skip, okay? So, and then we use social media, multimedia to study a bunch of social problems. This one was related to underage drinking. So underage drinking is a big problem in the US. And the current way CDC used was to send out surveys to high schools and ask. So the yield rate is not high, because that's not something you want to let everyone know. So not many kids respond to that. And also, since this is sensitive subject, they may not tell you the truth, okay? So we decided we want to study this problem, number one, at a larger scale. So this questionnaire or survey is like a few thousand people. So we want to use social media to study this problem. So it's important to use a social media platform where the population you target actually use very often. And it turns out for teenagers, their favorite social media platform is Instagram by a wide margin. So why is Instagram popular? Because it doesn't have any restrictions. It doesn't ask you age. It actually doesn't store much information at all, which is an issue for us. How do we know which ones are teenagers? So we need to figure that out. So I have a teenage daughter, so I thought, I asked her, I said, how many selfies you post on Instagram each month? She said, I don't know, 30? So that's great, okay, because selfies are pictures of themselves, right? Once we get that, we can use face analysis to figure out age, gender, race. And if you do it on one face, the state-of-the-art face recognition algorithm or age recognition has an error of plus minus 5 years, which is not an issue for someone like me. If I'm 5 years off, I'm still the old guy. But teenager, if you are 5 years old, you could be legal, could be illegal, right, for drinking. But the good thing is they have so many selfies, you can estimate on each one of them, you aggregate. And actually, you can cut down the standard deviation to 1 year old. Then we are in business. So now we can identify on Instagram who are teenagers. Then the next thing is, how do you know who are drinking, right? So my students, they were sort of emboldened by deep learning. They say, well, I'm going to train a CNN and find all the bottles. And then I know who's drinking. It's actually very hard. The bottles are transparent, okay? We can't quite do it. But fortunately, we don't have to do it that way, because Instagram, when they post a picture, they actually say a few things. Obviously, they won't say, I'm drinking, okay? That's not cool, okay? They have their own terminology, internet slang. So they have certain secret words to tell each other, about drinking. So we actually get that dictionary from the internet, and we use NLP to figure out which posts are related to drinking, right? So now we know who are teenagers. We know which posts are about teenager drinking. Now we can do our pattern mining, and these are our results. This is 7 days of a week, 12 months of a year, 30 days of a month. So you can see that drinking happens a lot in the weekends. It happens a lot in the holiday season because there's no shortage in the supply of alcohol, because they can't buy it themselves, right? They have to get it somewhere from someone's home. So holiday season is their best opportunity. In terms of days of the month, it's largely flat, except there are some in the beginning of the month, because in US, a lot of holidays are in the beginning of the month. So that's when they're drinking. Then next thing we are interested in is what they are drinking. So how do you know what they are drinking? So sometimes they say it, like what brand they are drinking. So that's one source of information. The other source of information was, it turns out all these major alcohol brands, they have presence in Instagram. So the kids will follow them. So whichever brands they follow would tell us they are interested in drinking that brand. So we tracked over 50 brands. I'm only showing you 5 here, randomly picked. And the middle one is Heineken. It's a beer. And this is a breakdown in terms of age. So blue is over 21. This this French color is under 21. Okay, so it just tells us Heineken is mostly consumed by adults. That's not interesting. And then you look at Heineken in terms of gender. Heineken is mostly consumed by guys. Okay. And in terms of race, Heineken is mostly consumed by white people, followed by Asian people, and for some reason, black people don't like Heineken. Okay, that's what our data tells us. So you say, okay, not very interesting. Okay, this is the most interesting discovery. For young girls, they don't like beer. What do they like? They like vodka 1 and vodka 2. Okay, so I'm not telling you which one they are, but I know which one they are. So, like girls, they like these spirits. Okay, so we did it for drinking, but we use same methodology to track other activities. We call this collection of activities risky behaviors. So there's drug use, there's smoking, there's depression, which is a big deal, bigger than I thought. Eating disorder, text while driving, that's a big deal. So we could track all of these things. Just to say a little bit about how we track drug-related activities. So this work was actually done in collaboration with the New York State Attorney General's office. They help us label the data. So it turns out drug dealers rely on social media to do their business. And then even law enforcement knows. So what they do is now they hire a bunch of interns to go through the Instagram post to figure out who are drug dealers. It's actually not as hard as you might think. It turns out the drug dealers are quite blatant in social media. They just say, "I look at the weeds I have. Okay, you can get it Thursday at this gas station." Right? It's just like that. Okay. So so law enforcement now they have people sitting there just to catch this kind of thing. Obviously, it's like finding needles in haystack, right? So we want to do it automatically. So this is what we did. So we have a dictionary of drug-related hashtags, keywords, and then we trained image classifier to recognize weeds, syrup, and pills. And then we put all things together, and we are getting accuracy of 90%. I want to give you the idea of what 90% is like. 90% is, so they hire interns to do this job. So they have a supervisor. So we treated the supervisor label as ground truth, right? You can measure the performance of interns against supervisors labeling, and then our algorithm against the super. So what I'm saying is this 90% is essentially saying our algorithm is as good as an intern. Okay. And then once we find that, we can find interesting pattern. This is the consumption of weeds by days of the week. This is pills. So weeds, that's interesting. This is 24 hours of the day. There are 2 peaks. Okay. I didn't know why there are 2 peaks, but then my students, they have some friends who actually use drugs. Okay. So they said, wow, this thing at 4 o'clock actually corresponds to this thing called 420. Okay. So there's the first peak. So they consume some, and then so they can last a little while, so they can go out and consume more. Okay. And for pills, there's no such pattern. Okay. And then some geotech tweets we can actually figure out where these hotspots of drug-related activities are. So this is Manhattan. There are these 2 places. There's a cafe and some neighborhood. Okay. I want to skip this. I want to mention this just briefly. So air quality in China especially is a big issue today. So people are so worried about it. So it turns out, but there are only 12 sensors in that big city of Beijing. So what we developed was to use tourist pictures to estimate the air quality at a given time on a given day or given location. And we were able to report, so we actually have ground truth. So the ground truth was what the US Embassy in Beijing released. So we are getting a very high correlation, 0.88, just from using tourist pictures. So San Francisco. San Francisco was it is one of the worst traffic cities in U.S. The worst one, as I just discovered, is LA. It's worse, a lot worse than here. New York is second. But there was some interesting observation that when you are stuck in the traffic, you look around, you don't see many luxury cars. So you say, wow, do they know something I don't know? It turns out, no, okay? It's because they have a different working schedule, if they work at all, okay? So these are the patterns. So we track, this is Seattle. We tracked a bunch of public cameras. Like we get one picture every second. Not every second, yeah, every second, okay. So, and then we do car model recognition and we compile these things. So this is Volkswagen, this is Toyota, which gives you, so these are the, so they show two peaks during the day, one at 8, one at 5. So it just tells you that Toyotas and Volkswagens are working class cars, right? Because that's what people drive. And then you look at the Fiat, okay? We don't come out during the day much, except very late. We also find some cheap cars, which I won't mention the brands. Their first peak is at 6 instead of 8. So some low-income people actually come to work a lot earlier than others. Fashion, okay, fashion is a more uplifting topic, I think. What we studied, this was last year, we studied is, we look at the images from the Fashion Week, and then we use computer vision technique. So these are black, low sleeves pants. They were not done by human. They were done by machines. So then we know for 2014 New York Fashion Show in February, these are the featured features. Okay, it's awkward. Okay, and then because those designs were intended for spring and summer, so after a few months we collect pictures for New York as well. And then we get these what we call street chic images, and we analyze the clothing feature as well. Okay, and this is what we get. What we are seeing, so we actually categorize the clothing-related feature in terms of the design feature, style, the patterns they use, the colors they use, okay? So this is for the fashion show on the left, and then street chic. So you can see that some of these design features did transfer to the main street, so people stop them, or adopt them, but not everything. Like this feature, it was there, but not on the street. And we actually analyzed those, and we find out some you can easily explain. For example, in 1 year, the Fashion Week features no sleeve dresses, but that spring was super cold. Obviously, nobody's going to wear short sleeve. Okay, so this is our early work. We just did something one step further. So we get the clothing sales data from Alibaba. And we were able to analyze using data mining technique and computer vision technique. We were able to figure out, okay, these best-selling clothes, why they sell well. Okay, we can identify which part of the design made them popular, made them sell, and then also what design is the least liked design. Yeah, we just finished that study. I think I'm almost done. I'll skip this. Basically, we're trying to use TripAdvisor data, the image data, in order to figure out if you have an occasion, you know, if it's formal, casual, trendy, or reunion, whatever, what restaurant is best suitable for that. Given I'm out of time, so I'm going to skip that. I'll just end on this note. These are what I believe are the open issues in using social multimedia in particular. Obviously, we need to deal with heterogeneous data modalities. And typically, you have to consider all the data modality as interrelated in a heterogeneous information network. And the third point is just given the advance in computer vision, now we can do more and more with images, right? Extract more information from visual data. But still, I think like text information, image information, we need to separate the noise from the signal. Okay, we still do a lot of geospatial analysis. Mobile platform becomes more important because we can get context information. One thing I want to mention is I show you quite a few things. In each project, the hardest part, okay, I want to say 50% of the work was about collecting data, as you can imagine. As an academic, I really hope we can work with companies so we can save that effort. Obviously, we need to search for killer apps. Finally, I just want to assure you that it's a sensitive topic. Okay, we can know more and more about users. That involves privacy, this and that. But what I'm saying is, if bad guys are doing it, we better do it for social good. Okay, so that's my argument. Thank you very much.